Now, to solve a system by using elimination, you can tell from the name that we're going to be getting rid of something. We're eliminating something. And we will be eliminating one of the variables at a time until we only obtain a single equation with a single variable. So to start this conversation, we can look at equivalent systems. So two systems are equivalent if they have the same solutions. So here are three systems. Notice the first equation is the same in each of them, but something's happened in the second equation so that these are all equivalent, but notice in our last system we can tell exactly what y is. And if I can tell what y is, we can go back and we can find out what x is. Now it might be easy to tell what happened between our second system and our third system. We divided both sides by 2 to obtain y equals 9. But how did we get from here to here? There are multiple ways that we can obtain equivalent systems. So we can interchange any two equations. So I can switch these two if I wanted. I can multiply or divide both sides of an equation by something that's not 0. So for example, from here to here, we can multiply both sides by 1/2. And we obtain y equals 9. And then lastly, we can replace any equation by the sum of that equation and a non-zero multiple of any other equation. So let's take a look at an example. Here I've numbered the equations to make it easier. So we are going to take and eliminate, in this case, the x's. Now you can eliminate y's if you wanted to, but for this case I just decided to eliminate the x. So we can multiply the second equation on both sides by -3. This multiplication of -3 would allow the coefficients to be equal but opposite. So 3x and -3x are now able to be eliminated because what we can do is we can replace this second equation by the first equation plus the second equation. So 3x and -3x goes away. 5y and -3y yields 2y. 60 plus -42 is +18. Now we can multiply both sides of our second equation by 1/2, and that gives us our y equals 9. But if y equals 9, we would have 3x plus 45 equals 60, which would mean that x equals 5. So the goal in solving by elimination is to eliminate one of the variables at a time, at least. So in this situation, if we try to eliminate one of the variables, what can we do? We can easily eliminate the x's. We could try to eliminate the y's, but let's go ahead and obtain equal but opposite coefficients for the x's. So to do that, we can multiply both sides of our second equation by 3. Now, what I'm not doing is I'm not putting parentheses around the equation. That doesn't make sense. You can't multiply an equation by a number. You can multiply both sides of an equation by a number. So the way we denote that is a vertical bar to the right of the equation, and then I'm multiplying it by 3. So the first equation doesn't change. We have 6x minus 12y equals 12. And then our second equation becomes -6x plus 24y equals -9. Now we can replace the second equation by the sum of the two equations. So our first equation won't change. We're replacing the second equation with the sum of the two. So 6x and -6x add out. 24y and -12y give us +12y equals, now if we take 12 and add -9, we get +3. Now we can take our second equation and we can multiply by 1/12. So our first equation doesn't change. We have 6x minus 12y equals 12. And then we have y equals 1/4 for our second equation. So let's back substitute. So we have 6x minus 12y equals 12. 6x minus 12 times 1/4 would equal 12. 6x minus 3 equals 12. So 6x would equal 15. And so x would equal 5 halves. So our solution is x, comma, y. 5 halves, comma, 1/4. Let's try our second system. Example 5. So we have 8x minus 10y equals 2, and negative 12x plus 15y equals 1. So let's go ahead and try to find coefficients that would be equal and opposite. If we look at the y's and try to eliminate the y's this time, they already have opposite signs. So 10 and 15 both go into 30. So we can multiply our first equation by 3 and our second equation by 2. And so our system that results would be equivalent, and it would be 24x minus 30y equals 6, and negative 24x plus 30y equals 2. Now let's replace the second equation by the sum of the two equations. So if I add the two equations, we get 24x and negative 24x. They eliminate. Negative 30y and positive 30y eliminate. So this gives us 0 on the left. And on the right, we get 6 plus 2, which is 8. Now, look at this second equation that results. Both variables got eliminated. We have 0 equals 8. Now remember, solutions to equations make true statements. 0 equals 8 is never true. So therefore, there is no solution. We call such a system inconsistent. Whenever there is no solution, the system is inconsistent. Let's look at another one. Let's look at this one, and which variable would we like to eliminate? It doesn't matter. Let's choose to eliminate our y's again. Well, this time we have a similar situation. We have 10 and 15, so they both go into 30. So let's multiply the first equation by 3, but the second equation we're going to have to multiply by 2, and we're going to have to make it negative so they have opposite signs. So we have 6x plus 30y equals 6. We have negative 6x minus 30y equals negative 6. Let's replace the second equation by the sum of the two equations. This time we get 0 equals 0. This is always true. So what's that mean? It means there are infinitely many solutions. So we know that 6x plus 30y equals 6 would mean that 30y equals negative 6x plus 6. So y would equal negative 1/5 x plus 1/5. And so what are the solutions? The solutions are any point x, y, where y equals negative 1/5 x plus 1/5. So what happens here is these two lines are coincident. They coincide. So if we graph them, one line falls on top of the other line. They intersect everywhere. Whereas in example 5, if we would graph those two lines are parallel, they never intersect. These two lines are what we call dependent equations. So this is a consistent system. Consistent just means that there is a solution, but the equations are dependent, which means that one of the equations at least is redundant. So, key thing is, how do we write our answer whenever there are infinitely many solutions? We have curly brackets to denote that this is a set. It is a set of ordered pairs, and the ordered pairs must satisfy this equation. The ordered pairs must be on this line. What line is that? It's the same in both cases, but all I did was solve one of our equations. Oh, I did this one. I could have solved 2x plus 10y equals 2, and that would have given us the same thing. So just take any one of our equations that has both variables and solve for one of them.